Greetings to the whole world, Java Absolute Beginners. It's Luandile here, the leader and the instructor of Maniqua School. And right now I'm about to dive onto the second exercise, which is named exercise 6.2. And again, you guys, I am not planning on reading through this exercise because I've already did. Besides, it's not like you cannot pause the video and go through it yourself. So without any waste of time, essentially we're summing the sum of digits here. So suppose we're given a number like 2, 3, 4. The method that we are required to implement is the one that will give us the sum of those digits. Okay. Let me create a class. I'll call it exercise 6_2, and then I'll go B. Of course, I need a main method. Okay, remember you guys, in the previous solution I mentioned that there are actually two ways you can go about doing this. Okay, in general, whenever you're working with any problem, you can use this approach, and I did apply the first one in the previous solution. And these two approaches are, I cannot quite recall their name because they've got their name, right? Ideally though, what you do is, in the first one, you pretend that you start by creating your methods and assume that they already work. Okay, like they are implemented and they work correctly. You simply start by focusing on your main method. Again, the idea applies to huge projects as well. Okay, from token projects that includes multiple developers. Okay, and the second approach is you start by focusing on the building blocks of your program or solution or application or whatever. By building blocks, I'm talking about the methods themselves, right? You start by implementing them and forget about the bigger picture of the application. I know this might sound confusing for now, you guys, but you will see what do I mean later. Some digits. Okay, and right here we're receiving nothing else but a variable, a parameter whose data type is an integer. Now here's what I'm referring to by focusing on the building blocks and forgetting about the bigger picture of the application. In this problem, what we would want to do is to forget about what's going on, or rather what is required. What are the requirements for the application? So think of this as a huge project, right? So you don't want to think about everything else, right? You don't want to think about the user story. You don't want to think about all the software engineering steps, right? What you want to think about is the very tiny pieces of the solution to be given. And right now I'm about to dive onto this one here. If you did recall before, what we did is we did validate, we did make sure that we're working with non-negative integers, right? However, even though this solution did work out fine, but it is not considered as a good way of doing things, in a way that you see the part that actually does the validation shouldn't be embedded in our main method. If you think of it carefully, it will be a good idea if we had to just take it and then put it where it's supposed to belong, which is right here within this method. Okay, and right now it is precisely what I'm going to do. So I'll simply go, and I could do this, you guys. N is equal to method ups n. Okay, and then I do that. Now my n value will always be positive. Okay, I will then do what? I will then define a variable called total. Okay, I will then go while n let me do this, you guys. The reason why I want to do it this way is so that that I did not mean. The reason why I'm doing it this way is so that in the next solution I'll point certain things out. Okay. Okay, as long as that is greater than 0. So ideally here I'm making sure that I'm working with n as a positive integer. Okay, I will then go total is equals to total plus n mod 10. Remember that line right there, math.ups is an absolute value of n, but if we had n as a negative number, it doesn't mean that that n right there will be treated as a positive number. It will be treated as a negative number. It is only in that line there, in line 13, that we treat n as a positive number. However, modding a negative number will result in the same thing as modding a positive number. Okay, of course, assuming that number is the same. Could I be missing? I really cannot believe I'm required to typecast that. I will then go n is equals to n divided by 10. Okay, that should be it for my tutorial, you guys. Now the next thing I would have to do is to go total. Okay, again, the takeaway here is, you guys, there's also another approach when it comes to working with methods, programming in general, and that approach is you start by focusing on the building blocks, on the very tiny detail of the program, and then work your way up to the bigger picture of the problem on hand. And right now I'll get started. Probably I shouldn't bother myself much about this part. I can simply copy and paste what we already have here. Okay. Oops. Okay, the only thing that I want to get rid of is that portion there. Okay, with it out of the way, I'm good. Okay, now let's see what we have. Run. As expected. See, you guys, it seems like we're good. We have a working solution. 24 as expected. Okay, so that's gonna be it for this tutorial, you guys. Again, you see, even if I'm entering a negative number, it will work out fine. It won't. It won't. And the reason for that is, again, I would have to go. You see, by doing that, I'll have to go in order to make sure that our number is never negative. Okay, I'll have to use the absolute value. And the reason why I'm gonna talk, you know what, you guys, I'm gonna give you out another solution on this same exercise at that one, which will be responsible for pointing out certain things I don't quite like about this solution. You know what, you guys, we can, of course, let me do it here because I don't want people to think that I'm explaining some things unnecessarily. You see, one thing I did not like about this exercise here, you see, on each iteration we were computing the absolute value of n, right? And that right there is considered as an inefficient solution, right? Because we computing the absolute value of n even if n is positive, and if it happens to be negative, we'll keep, suppose we've got a number such as 1234, which is minus 1234, which is minus 123. In the way I've done it previously, let me start by showing these to you guys. The way I've done it previously was inefficient. Okay, as you can see, we have a working solution. And the reason for that is, you see, on each iteration, this is the correct approach. On each iteration, we're computing that. So in this example, on iteration 1, we would compute my absolute value of minus 1234. On the second iteration, we'll compute the absolute value of minus 123. On the third iteration, we'll compute the absolute value of minus 12. On the fourth one, minus 1. Okay, we'll then stop. Now the problem with that is, you see, of course, in this example, it's not like it makes much of a difference, but the idea here is you gotta try to be as efficient as you can. Okay, avoid inefficient code. Okay, and another thing is, even if our number is positive, you see the way I did it before, I was still computing the absolute value of a positive number, which is unnecessary, you guys. Okay, I thought I should just explain that on this solution here rather than giving you guys another one. So that's gonna be it for this tutorial. Cheers, you guys, I'm gone.